Yeah, good evening, boys. Good evening, online students.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Yeah, good evening. I've shared my screen. Is it visible?
Yes, ma'am.
Okay.
Yes, ma'am.
All right, children. So, before we start, I have to tell you that the presentation on, we actually started with probability in the last class. I don't know, suddenly I'm not able to find those files. Probably by mistake, I moved it, I deleted the files or whatever. So that is why last minute I just thought I'll start off with trigonometry. So I'll retrieve my files. They're all there. I'm not able to find it. Sometimes, like I would have just accidentally moved it. So I'm not able to find the files, which is the reason why I'm again starting a new chapter, trigonometry today. Trigonometry also was not planned. So I thought, okay, fine. I could do even triangles. Triangles, have you learned in school, children here? Similar triangles? No, you have finished. Okay, just like that, I thought, okay, fine, then let's start trigonometry. So we're not going to write anything in today's class. There's nothing to write. It's all derivation. The introduction is all about derivation of trigonometric identities and other stuffs. So just listen and you can take screenshots later. All right. All right, children. So what is trigonometry? Trigonometry is a branch of mathematics like statistics. Statistics is a branch of mathematics. So like that, trigonometry is a branch of mathematics that deals with the study of the relationship between the sides and angles of a right triangle. So 10th standard, we restrict the study of trigonometry to right triangles. All right. So I'm talking with respect to our syllabus. So trigonometry is a branch of mathematics that deals with the study of the relationship between the sides and angles in a right triangle. Okay, so that is what is trigonometry. Like what is statistics? Again, it's a branch of mathematics that deals with the collection, organization, analysis, and interpretation of data, numerical data. So like that, I repeat, trigonometry is a branch of mathematics that deals with the study of the sides, deals with the study of the sides, the relationship between the sides and the angles of a right triangle. So in this chapter, the key words are trigonometric ratios. Trigonometric ratios. So we understood the term trigonometry. So here you can see, how this word was formed. So the word trigonometry is derived from the Greek words, three Greek words, tri, gon, and metron. So how was this branch of mathematics named trigonometry? How was this branch of mathematics named trigonometry? So using these three Greek words, tri meaning three, gon meaning sides. See, like we say polygon, right? Polygon. What is a polygon? It's a closed figure made up of line segments. Line segments, no? So that's why gon means sides, line segments. Polygon, polygon, polygon. Polygon is a closed figure made up of line segments. Line segments. So here also, gon means sides, meaning sides are line segments, right? Sides are line segments. So gone and metron, meaning measure. Measure is about the angles. Measure is about the angles. So the three words, tri meaning three, because a triangle has three sides. Of course, it has three angles also. So tri meaning three, gone meaning sides, and metron meaning measure. Measure. All right. So that's how it's derived. So it's derived, the word trigonometry, good evening. The word trigonometry is derived from three Greek words, tri, gon, and metron. Tri meaning three, gon meaning sides, and metron meaning measure. Right? Okay. So now, what is an identity? When we say an algebraic identity, okay, when we say an algebraic identity is an equation. Okay, an algebraic identity is an equation. See here, what is an algebraic identity? Let's write an algebraic identity. So like a plus b, the whole square is equal to a square plus 2ab plus b square. So this is an algebraic identity. What is this? This is an algebraic identity. Identity. And it's an algebraic, an identity is always an equation. When we say an identity, it's an equation. An expression is not an identity. If you have an expression is not cannot be an identity. An identity is always an equation. And why is it called an algebraic identity? Algebraic because it's made up of variables. It's made up of variables, and you can see the constant also here. So because algebra is made up of variables and constants, right? In the study of algebra, we use a lot of variables and constants. So algebraic identity, identity meaning it's an equation. Algebraic identity because it uses variables and constants. So here this is an algebraic identity. A plus b the whole square is equal to a square plus 2ab plus b square is an algebraic identity, which involves the variables a and b and the constant 2. You can see the constant 2 there and variables a and b. And it's an equation. It has the LHS and the RHS. It's an equation. So it's made up of variables and constants. It's an equation, and it's true for all the values of the variables involved. Whatever be the values of a and b, this equation will be true. You give any value for a and b, like you take a is like root 3 by 2 and b as some minus 5, and substitute here, the LHS and RHS value will be the same. That's why it's called an identity. An identity is an equation which is true for every value of the variables involved. Whatever be the values of a and b, this identity will hold good. You can take any values for a and b and find the value of the LHS and RHS separately. Give some value for a and b, work the LHS separately and RHS separately. You will see that the LHS and RHS will have the same value. That's why it's an identity. So like this, a trigonometric identity is an identity which is constructed using trigonometric ratios. An identity having trigonometric ratios is called a trigonometric identity. Again, an identity meaning it's an equation. It has the LHS and RHS. It's an equation, and it's true for every angle involved in the variables. The variable there is the ratio, the trigonometric ratios. So let me write one trigonometric identity and then explain what it is. So these are the three main trigonometric identities. In fact, sine square theta. No, now if you have not learned in school, you will not understand. Just listen to this. So sine square theta plus cos square theta is equal to 1 is a trigonometric identity because it has trigonometric ratios sine theta and cos theta. Cosecant square theta minus cot square theta is equal to 1 is another trigonometric identity because it involves trigonometric ratios cosecant theta and cot theta. Secant square theta minus tan square theta is equal to 1 is another trigonometric identity, not algebraic, trigonometric identity because it involves the trigonometric ratios secant theta and tan theta. In fact, these are the three very important trigonometric identities which you will learn. These are the identities we have. The three major trigonometric identities. So here you can see all the ratios. Sine theta. These are the 6 ratios. Sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. Well, we'll understand all this in detail. I just gave you, I just wrote these identities to tell you what a trigonometric identity is. So these are trigonometric identities. Why? Because they involve trigonometric ratios. Algebraic identity involves constant, not algebraic ratios. Variable, yeah. So it has something of algebra, variables and constants. So it's an algebraic identity. Trigonometric identity involves trigonometric ratios. Okay. So that's about. So see here. Look at this one. This one. Read these two. An equation which involves algebraic variables and is true for all values of the variables involved is called an algebraic identity. An equation, an identity is an equation. An identity is an equation. An identity is an equation. An equation which involves algebraic variables and is true for all values of the variables involved. Any value you give for A and B, the identity will hold good. It's called an algebraic identity. What's a trigonometric identity? An equation. An identity is an equation which involves trigonometric ratios of an angle and is true for all values of the angle. See, like when we said sine theta, theta is an acute angle. Theta is an acute angle. So which holds good for every angle, every value of the angle involved. Which holds good for every value of the angle involved. Now, what is this trigonometric ratio? What is this trigonometric ratio? Okay, so now I'll just define this trigonometric ratio sine theta. I'll just define this trigonometric ratio sine theta. Sine theta is equal to opposite by hypotenuse. Opposite by hypotenuse. Okay, so it's the side opposite to this angle theta by the hypotenuse. So sine theta is equal to opposite. Now, for example, in this right triangle, if this is theta, this is 1 minute. Let me draw more near. Okay, so which is a side opposite to theta? BC. The side adjacent to theta is AB. And AC is the hypotenuse. AC is the hypotenuse. So here we'll be using these 3 terms: opposite side, adjacent side, and hypotenuse. Hypotenuse, we all know, is the side opposite to the right angle. Okay, so the remaining 2 sides will be the opposite and adjacent side. Depending on where, or with respect to the angle you're talking about. The opposite and adjacent sides are not fixed. It's not that this is the opposite side, this is the adjacent side. No. Opposite and adjacent sides depend on the angle which you're using. With respect to the angle it is. So a triangle has 3 sides. A right triangle, 3 sides. 1 side is the hypotenuse. Remaining 2 sides, one will be the opposite side, the other will be the adjacent side. And now that depends on the angle. Okay, so supposing you talk about this angle. This angle. Theta, you call it theta. Again, theta is a Greek letter. You say theta. The side opposite to theta is BC. The side opposite to theta is BC. And the side adjacent to theta is AB. Because AC is the hypotenuse. AC cannot be the opposite or the adjacent side. The hypotenuse is never the opposite side or the adjacent side. The hypotenuse, because you'll always take an acute angle. Okay, fine. So you remember like this. So the hypotenuse is never the opposite side or the adjacent side, because you'll always be are taking an acute angle in this triangle. So these are the two acute angles, this one and this one. Let me say alpha. So with respect to theta, this is the opposite side and this is the adjacent side. With respect to alpha, this is the opposite side, this is the adjacent side. So when we say opposite and adjacent, see, we are not looking at the hypotenuse at all. Hypotenuse is the hypotenuse. So, and we'll always talk with respect to an acute angle. We will always talk with respect to an acute angle. So in the right triangle, this is 90 degrees. Don't talk about this angle. Talk about the remaining two acute angles. The remaining two acute angles. So if you're talking with respect to theta, this angle theta, this is the opposite side. So automatically this becomes the adjacent side. All right. If you're talking with respect to alpha, this is the opposite side. So automatically this becomes adjacent side. Hypotenuse is not taken into consideration at all. That is the hypotenuse. Okay, so right triangle PQR. If you take this acute angle as theta, for theta, this is the opposite side, correct? This is the adjacent side. The other side is the adjacent side. This is the hypotenuse because it's opposite of the right angle. If you mark this angle and call it beta, opposite of this one, this is the opposite. For beta, this is the opposite side. For this angle beta, this is the opposite side. Excuse me. Opposite and adjacent sides are marked with respect to an angle, not simply like that. Okay, let this be the opposite, let this be the adjacent, not like that. Opposite side and adjacent side are marked with respect to an angle. For this angle, this is the opposite side. So this is the adjacent side. For another angle, this is the opposite side. So the other one is the adjacent side. Hypotenuse is the hypotenuse. Is that clear? Okay. So now a trigonometric ratio. Now we were talking about a trigonometric ratio. A trigonometric ratio establishes the relationship. Now I'll say sine theta is equal to opposite by hypotenuse. So this is the trigonometric ratio. This one is a trigonometric ratio. Now this trigonometric ratio expresses the relationship between the angle and the two sides of a triangle. See, trigonometric ratios actually sine theta, cos theta. These are trigonometric ratios. Now look at the way it is expressed. The trigonometric ratio. How is it expressed? Sine theta is equal to opposite by hypotenuse. Sine theta is equal to opposite by hypotenuse. So it connects an angle and theta is an angle of the right triangle. Theta is an angle of the right triangle. Theta is an angle of the right triangle. And what are these two? The sides of the right triangle. So what is this trigonometric ratio? What does this trigonometric ratio say? It connects an angle with two sides of the triangle. It establishes a relation between this angle and the two sides. It says sine of this angle is equal to opposite by hypotenuse. So this ratio is establishing a relationship between this angle theta and these two sides. Correct? Similarly, we say that cos theta is equal to adjacent side by hypotenuse. So cos theta, this is again a trigonometric ratio. Cos theta is again a trigonometric ratio. It establishes the relationship between this angle theta and these two sides of the right triangle. So that is what is a trigonometric ratio. The trigonometric so sorry. Just a second, children. Yeah. Yeah. So the trigonometric ratios. The trigonometric ratios of an acute angle in a right triangle expresses the relationship between the angle and the length of its sides. I'll read it slowly. Okay, the trigonometric ratios, they talk about all the ratios. Generally, a trigonometric ratio. So here the trigonometric ratios. Okay, so what are the trigonometric ratios? I told you sine theta, cos theta, tan theta. So these trigonometric ratios of an acute angle, the angle should be an acute angle. When you say sine theta, cos theta, the theta is an acute angle. So the trigonometric ratios of an acute angle in a right triangle expresses the relationship between that angle, that acute angle theta, and the length of its sides, some two sides. Is that fine? So trigonometry, what is trigonometry? You can see here. What is trigonometry? Trigonometry is a branch of mathematics that deals with the study of the relationships between the sides and angles of a triangle. That is trigonometry. And how did this word trigonometry originate? It's derived from the Greek words, three Greek words: tri, meaning three, gon, meaning sides, and metron, meaning measure. Algebraic identity is an equation. Identity is an equation, and algebraic means it involves variables and constants. Trigonometric identity is again an equation. Trigonometric identity is again an equation, and it involves trigonometric ratios. All right. Luckily, you don't have to define anything. You just have to have the understanding. Mostly you're not asked define this, define that. So you just need to understand what a trigonometry. So you should remember that trigonometric identity is an equation and it has trigonometric ratios. And the ratios have an angle theta in it. And the trigonometric identity will be true for every angle of theta. Whatever you give, whatever angle you give for theta, the identity will hold good. Whatever value, whatever angle you give for theta, acute angle you give for theta, the identity will hold good. The LHS will be equal to the RHS. So that's an algebraic identity, trigonometric identity. Now trigonometric ratios. So we said sine theta, cos theta, tan theta. Why are these ratios? Because they connect, the trigonometric ratio connects the acute angle and the length of the two sides of the right triangle. Yeah. Online students, is it clear so far?
Yes, ma'am.
Yes.
Yes,
So,
ma'am.
so far we've come across the terms trigonometry, trigonometric ratio, trigonometric identity. That's it. All right. Okay. So these are the 6 trigonometric ratios. Sine A, or see, A is the angle here. So it is sine theta, or you can call the acute angle by any letter. It can be any capital letter from A to Z. The angle can be represented using any capital letter from A to Z, or some Greek letter like theta, beta, alpha. Okay, so the sine and this one represents the acute angle. This one represents the acute angle. Okay, so let me read the ratios for you. So sine A, cos A, where A is the angle. Tan A, don't get confused. She was saying theta and suddenly she's saying A. Anything it can be. It can be theta, beta, alpha, gamma, A, B, C, D, anything. But A, B, C, D is capital A, B, C, D, not small A, B, C, D. So tan A. Okay, so I was saying sine A, cos A, tan A, cosecant A. Sometimes they say cosec A. So pronunciation varies. You know, my generation, cosecant A. Now, cosec A. Maybe, I don't know. So you use the pronunciation your teacher uses in school. Okay, normally we believe that, right? You believe your school teacher more. So cosec A, that's what I've heard in schools here. But well, I'm used to saying cosecant A. I'm used to saying cosecant A. Both are correct. Cosec. This people say cosec. I say cosecant A. Secant A. Secant A. So they say sec here. Sec. No, I don't say sec. I say secant A. And cot A. And cot A. Sin A. Sin A. Sin A. Cos A. Tan A. Cosec A or cosecant A. Sec A or secant A. Cot A. Okay. The full forms are sine with an E. The pronunciation doesn't change. The spelling is different. Sine of angle A is shortened as sin A. Or sin A is a short for sine of angle A. Instead of saying sine of angle A, it's shortened as sin A. Cosine of angle A. Cosine of angle A, shortened as cos A. Cosine of sine, cosine. Tangent of angle A, or simply tan A. Tangent of angle A, or simply tan A. Cosecant, cosecant of angle A, or cosec A, or I say cosecant A. Cosec A or cosecant A. Secant of angle A, secant of angle A. Sec A or secant A. Cotangent, like you say cosine here, cosine, cotangent, tangent, just put a CO in, before that, cotangent of angle A or cot A. All right. Okay. So these are the three main trigonometric ratios: sin A, cos A, tan A. These are the three main trigonometric ratios. Cosecant, secant, and cot are reciprocal ratios. Cosecant A, secant A, and cot A are reciprocal ratios. The reciprocal of sine is cosecant. The reciprocal of cos is secant. The reciprocal of tan is cot. See, I'll say sine, cos, and all that. This has no meaning. When I say sine, it does not. Sine does not exist without an angle. Sine theta. There's no meaning. Sine has no meaning without an angle attached to it. Sine theta, sine of which angle? Sine theta. Cos of which angle? Cos theta. Tan theta. So the ratio is always with the angle. Simply if we write sine square like this, sine square theta plus cos square theta, like this is equal to 1, this is wrong. There's no angle at all there. This becomes English kind of. There's no angle at all there. All right. Okay, so sin A, cos A, tan A. These are the three main trigonometric ratios, and their reciprocal ratios. The reciprocal of sin A is cosecant A. The reciprocal of cos A is secant A. The reciprocal of tan A is cot A. So let me write it here. Sin A, cos A, tan A. Sin reciprocal is cosecant A. Cos A is secant A. And this is cot A. Reciprocal. They're not equal. Reciprocals. So you can see if it is S here, it is C here. If it is C here, it is S here. Sin A reciprocal is cosecant A. Cos A reciprocal is secant A. Tan A reciprocal is cot A. These are the three main trigonometric ratios, and these are the reciprocal ratios. These are the reciprocal ratios. Okay, now let's see their definitions. So sine of angle A or sin A is the side opposite to angle A by the hypotenuse. So in this figure, this is angle. See, this is A. This is angle A. So opposite to angle A is this side. So this is the adjacent side. And this is the hypotenuse because it's opposite to the right angle. Hypotenuse is this one, opposite to angle A. And this is the adjacent side. All right? All right? Okay. So what is sine A? Sine A is equal to opposite by hypotenuse. The side opposite to angle A by hypotenuse. So BC by AC. Cos A, cosine of angle A or cos A is a side adjacent to angle A by the hypotenuse. So this is the side adjacent to angle A, AB by AC. Tangent of angle A or tan A is a side opposite to angle A by the side adjacent to angle A. Opposite by adjacent. Opposite by adjacent. Sine and cos have hypotenuse in the denominator. Tan has no hypotenuse. Opposite by adjacent. Opposite by adjacent. Side opposite to angle A by the side adjacent to angle A. And these are the reciprocals. You can go through this and understand. These are the reciprocals. So cosecant A, see, cosecant A, the reciprocal of cosecant A is sine A. But you cannot write cosecant A is equal to sine A. This is wrong. Cosecant A is not equal to sine A. They are reciprocals. So how do you write that? How do you show that they are reciprocals? Cosecant A is equal to 1 by sine A, or sine A is equal to 1 by cosecant A. Don't write sine A is equal to cosecant A. They are not equal. Sine A is 1 by cosecant A, or cosecant A is 1 by sine A. Okay, so cosecant A is 1 by sine A. So it's a reciprocal of sine. So what is sine? What is sine? This one. So reciprocal will be hypotenuse by side opposite to angle A. Hypotenuse by side opposite to angle A. Secant is a reciprocal of cos. What is cos? This one. Side adjacent to angle A by hypotenuse. So it will be the hypotenuse by side adjacent to angle A. And cot reciprocal is tan. So what is tan? Opposite by adjacent. So here it will be adjacent by opposite. Adjacent by opposite. Yes or no, children? Tell me. Sin theta is equal to opposite by hypotenuse. Cos theta is equal to adjacent by hypotenuse. Tan theta is equal to opposite by adjacent. Now cosecant theta is the reciprocal of sin theta. So hypotenuse by opposite. Secant theta is a reciprocal of cos theta. So hypotenuse by adjacent. Cot theta is a reciprocal of tan theta. So adjacent by opposite. All right. So sine OA. See, O, the hypotenuse is the denominator. So O opposite first, then adjacent, then opposite by adjacent. If you remember these three, these are easy. Sine is opposite by hypotenuse, cos is adjacent by hypotenuse. Then tan is opposite by adjacent. Then these are the reciprocals. Got this, children? All of you? So tell me, what is sine A? Sine A is equal to opposite by hypotenuse. Cos A?
Adjacent by hypotenuse.
Very good. Tan A? Opposite by adjacent. Opposite by adjacent. And what is the reciprocal of sine A? Now, what is the which ratio is a reciprocal of sine A? Cosecant A. Cosecant A. And what is it? Cosecant A. It connects which two sides? H by O. Hypotenuse by opposite. And what is the reciprocal of cos A? Which ratio? secant A, and it connects which two sides? H by A, hypotenuse by adjacent, and the reciprocal of tan A, cot A or cotangent A, cot A, which is adjacent by opposite, adjacent by opposite. Okay, so these are the 6 trigonometric ratios. 3 are the trigonometric ratios, the remaining 3 are the reciprocals. Now, when you see the ratios here, okay, look at this one. What is sine A? No, don't look at this, children. Don't look at this one. See here. What is sine A? From here, what is sine A? BC by AC divided by, what is cos A? So what am I doing here? I'm dividing sine A by cos A. This is sine A, this is cos A. I'm dividing sine A by cos A. So what do you get? BC by AC into AC by AB. So AC and AC gets cancelled and you get BC by AB. What is BC by AB? It's tan A. It's tan A. So that's what it is. So tan A is equal to sine A by cos A. Tan A is opposite by adjacent. That is there. Tan A is also sine A by cos A. Tan A is also sine A by cos A. We'll do that again. See here, what is sine A? See this one. What is sine A? BC by AC. We are dividing. Now don't ask me why you're dividing. You do anything. I'm just trying to show that this divided by this is something else. Now, there is no answer to the question, why are you using division? Why not multiplication? With division, you can establish this relation. That's all it is. So sine A is BC by AC divided by cos A. What is cos A? AB by AC. So BC by AC into AC by AB. So AC and AC gets cancelled. BC by AB. So you can see that ratio here, BC by AB. So that means tan A is equal to sine A by cos A. Tan A is equal to sine A by cos A. All right. Now let's divide the other way. We'll divide cos A by sine A. We'll divide cos A by sine A. What is cos A? AB by AC divided by, what is sine A? BC by AC. We first did sine theta by cos theta. Now we're doing cos theta by sine theta or cos A by sine A. Okay, so AB by AC into AC by BC. AC gets cancelled. So AB by BC. AB by BC. Where is AB by BC? See, AB by BC. So cot A is equal to cos A by sine A. Cot A is equal to cos A by sine A. I'll write this. What I've written here is also fine. I've explained in a different way now. That's all. You understood what I said? All of you? When you divide sine A by cos A, when you divide sine A by cos A, the ratio which we get is equal to tan A. And when we divide cos A by sine A, the ratio which we get is equal to cot A. So these are the other two relations. Tan A or tan theta is equal to sine theta by cos theta. Reciprocal. Cos theta by sine theta is equal to cot theta. And it's true. I mean, it's believable because tan and cot are reciprocal ratios, right? If tan theta is sine theta by cos theta, then cot theta has to be cos theta by sine theta. Because tan theta and cot theta are reciprocal ratios. Tan theta and cos theta, tan theta and cot theta, tan theta and cot theta are reciprocal ratios. So if tan theta is sine theta by cos theta, then cot theta has to be cos theta by sine theta. All right, children. Any questions, online students?
No.
Okay. Now we're going to derive trigonometric ratios of some specific angles. Okay, so the specific angles we'll be deriving for are 30 degrees, 45 degrees, and 60 degrees. We're now going to derive. Now we've been saying no, theta is an angle. Theta is an angle. So we're going to find the value of sine and give some value. Sine 30 degrees. What's the value of sine? 30 degrees. What is the value of sine? 45 degrees. See, everything has a value. Sine 0 degrees has a value. Sine 1 degree has a value. Sine 2 degrees has a value. Everything has a value. But again, in CBSE, you will be seeing only standard angles. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. These are the standard angles. And you will be mostly dealing with sine 0, sine 30, sine 0 degrees, sine 30 degrees, sine 45 degrees, sine 60 degrees, sine 90 degrees. Well, in the other syllabus, like the ICC syllabus, we have all, meaning not only standard angles. We'll be learning for all the angles. And we use a book called the Clark's table, which has all these, plus minus values for the trigonometric angles. So all that you don't have, it's a very simplified one. And now the portions are also diluted. Syllabus is diluted. You don't have complementary angles. One part of trigonometry is removed. Complementary angles is removed. 2 years ago, it was removed and it continues. Now they've diluted the portions right from 6th standard. Right from grade 6, they call it the rationalized syllabus. They call it the rationalized syllabus. They made the syllabus more rational. So that means all these years it was irrational. Okay. They're calling the syllabus as a rationalized syllabus. All right. So in the rationalized syllabus from grade 6 to grade 10, many portions have been deleted. Constructions. For 9th standard, even probability is deleted. You have 9th standard, no constructions. You also don't have constructions. 9th standard, a few chapters like areas of parallelograms and triangles. So that has been removed. Okay. All right. Yeah. So now we are going to derive trigonometric. What's the comment your friend is telling you? Sorry? நீங்க சிரிச்சுட்டே சொல்றீங்க புரியல. No, in some years to come, people will just do a basic education till 10th standard. Then they'll all identify themselves and start working on their interest. Slowly, all these degrees and all will appear. We see so many people, they study at IIM and IITs, and then they give up to become a YouTuber or an Instagram influencer or whatever. They start up a idli batter manufacturing unit. Really, they're all like, you can earn more than you would. You'll be slogging for somebody and you learn less. Everything, yeah, correct. So the stereotypes will be destroyed. Now, we respect children based on their academic. We meaning not me. I'm saying the world in general. We respect children based on their academic strength. He studies well, so he's a good boy. They're very bad. It's very bad. So all that is we should change on how we look at children. You must respect children for what they are, and not for what they are not. Yeah. Slowly in the rank system, when we were studying, we had ranks. First rank, second rank, third rank. Now you don't have that. Ranking is removed and now you have only grades. So things will change. We are seeing big changes in smaller periods. Like now changes don't need generations. It's not like when I was young. It's all happening now. I can see so much of difference. Like when I was young, then when I got married, now changes are just happening so fast. So 100, 200 years don't have to pass by for big changes. Big changes have happened. We didn't have mobile phones at all. Now mobile phones and so much beyond that is happening. Shashank is like, okay, you continue with trigonometry. Okay. So I was telling you that we are going to see, trigonometric. We are going to derive the trigonometric ratios for some specific angles, like sine 30 degrees, sine 45 degrees, and sine 60 degrees. So similarly, cos 30, cos 45, cos 60, tan 30, tan 45, tan 60 for all. Okay. So now, so the trigonometric ratios of 45 degrees. Trigonometric ratios of 45 degrees. So to derive the trigonometric ratio, see here we have derived what is the value of sine 45. I'm just telling you the end result. You should know what we are doing, right? See, finally, at the end of the process, you will be able to find that sine 45 degrees, the value is equal to 1 by root 2. Cosecant 45 degrees, because cosecant 45 is the reciprocal of sine 45. Cosecant 45 will be root 2, the reciprocal of 1 by root 2, which is root 2. Sine 45 degrees, the value is 1 by root 2. Cosecant 45 is a reciprocal of sine 45 degrees. So its value is the reciprocal of 1 by root 2, which is root 2. The value of cos 45 degrees is 1 by root 2. And the value of secant 45 degrees will be root 2. Why? Because cos and secant are reciprocal ratios. The value of tan 45 degrees is 1. Cot and tan are reciprocal ratios. So the value of cot 45 degrees is also 1 because the reciprocal of 1 is 1 itself. See here, I'll show the others also. So here you can see the derivation for 30 degrees and 60 degrees. So sine 30 degrees, the value of sine 30 degrees is 1 by root 2. So what will be the value of cosecant 30 degrees? Because sine and cosecant are reciprocal ratios. So cosecant 30 degrees will be root 2, the reciprocal of 1 by 2, which is root 2. Sine 30 degrees and cosecant 30 degrees are reciprocal ratios. Sine 30 degrees, cosecant 30 degrees. So if the value of sine 30 degrees is 1 by 2, the value of cosecant 30 degrees will be 2 by 1, which is 2. The value of cos 30 degrees is root 3 by 2. So its reciprocal, secant 30 degrees, will be 2 by root 3. The value of tan 30 degrees is 1 by root 3. The reciprocal of tan 30 degrees is cot 30 degrees. And its value is the reciprocal of 1 by root 3, which is root 3. So you can see here, sine 60 degrees is root 3 by 2. Cosecant 60 degrees is 2 by root 3. Cos 60 degrees is 1 by 2. Secant 60 degrees is 2 by 1, which is 2. Tan 60 degrees is root 3. Cot 60 degrees is 1 by root 3. Okay. Now, I'll just say something else. 1 minute. Now, you need to remember all these values. Okay. So what you do? Easiest is, like, just remember now, it's going to be like, you'll have to remember sine, cos, tan, cosecant, secant, and cot. Okay. Sine of 0 degrees, sine 30 degrees, sine 45 degrees. Now, you might think you said sine has no value and you've written only sine. See, it's read like the sine 0 degrees, sine 30 degrees, sine 45 degrees, sine 60 degrees, sine 90 degrees. Remember only the first row. Remember only the first row. See, different teachers have different ways of helping children understand the values. Sometimes you find mnemonics, some words which tell you the values. Very simple to remember. Just remember like 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Just remember these values. 0 and 1. The borders are 0 and 1. So it's easy. Leave those two. 0, 1. That's 1. That's easy. In the middle, you have 1 by 2, 1 by root 2. Like 0, 1. What comes between 0 and 1? Half, no? 0 and 1. What comes between 0 and 1? Half. So next value is half. Then 1 by root 2. So 1 by 2 is modified. 1 by root 2. Root 3 by 2. Just visualize these numbers. That's all. Just keep these numbers in your mind. The whole table you can write. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. 0 and 1, 1 by 2, 1 by root 2, root 3 by 2. That's all. I can tell you this in different ways, but all this is just a waste of time. This is so easy to remember. We remember so many things in history, civics, geography. For this, you don't need any clue. Basic numbers these are, right? Okay. Now write this in the reverse order. 1 root 3 by 2, 1 by root 2, 1 by 2, 0. Okay. Now for tan, you basically have to divide sine and cos because tan theta is sine theta by cos theta. Tan theta is sine theta by cos theta. So the value of tan will be tan 0 degrees. The value of tan 0 degrees will be sine 0 degrees by cos 0 degrees. Tan 0 degrees is equal to sine 0 degrees by cos 0 degrees. Like that, tan 30 degrees will be sine 30 degrees by cos 30 degrees. And so on. So what is tan 0 degrees? Sine by cos, 0 by 1, 0. Divide 1 by 2 by root 3 by 2. Divide and see 1 by 2 divided by root 3 by 2. So it will be 1 by 2 into 2 by root 3. So cancels 1 by root 3. 1 by root 2 divided by 1 by root 2 is 1, no? Something divided by itself. 5 by 5 is 1. 1 by root 2 by 1 by root 2, 1. Root 3 by 2 divided by 1 by 2 is root 3 by 2 into 2 by 1. Root 3. 1 by 0 is not defined. Division by 0 is not defined. It's not defined. So this also I'll say you don't have to divide every time. Again, remember, start with 0. Then write 1 by root 3, then only 1, then only root 3 and not defined. 0, 1 by root 3. Then 1 alone, root 3 alone, not defined. 0, 1 by root 3, 1 alone, root 3 alone, not defined. That's all. Now, for writing the values of cosecant, reciprocals of sine, reciprocal of, so cosecant 0 degrees, cosecant 0 degrees. Cosecant 0 degrees is the reciprocal of, no, you were looking at something, so I just saw what we were looking at. Cosecant 0 degrees, no, because he constantly looks at the watch. Vivekan will always see the watch. Okay. All right. Cosecant 0 degrees is the reciprocal of sine 0 degrees. Cosecant 0 degrees is the reciprocal of sine 0 degrees. What is sine 0 degrees? 0. What is 0? 0 by 1. What's the reciprocal? 1 by 0. So not defined. Sine 0 degrees is 0. 0 means what? 0 by 1. 0 means 0 by 1. So reciprocal is 1 by 0. 1 by 0 is not defined. Reciprocal of 1 by 2. 2. Reciprocal of 1 by root 2. Root 2. Reciprocal of this one. 2 by root 3. And reciprocal of 1 is 1 itself. Again, secant theta will be the reciprocal of cos theta. They're not equal, reciprocals. So if it's 1 here, it will be 1 here also. Root 3 by 2, so it will be 2 by root 3. 1 by root 2, so it will be root 2 by 1, which is root 2. 1 by 2, which is 2. 0. 0 means 0 by 1. 1 by 0, not defined. And finally, cot, reciprocal of tan values. So tan is 0 here. 0 means 0 by 1. 1 by 0, not defined. 1 by root 3. So root 3. 1, 1. Root 3, 1 by root 3. Not defined. Not defined means 1 by 0. Not defined means 1 by 0. So what will be the reciprocal of that? 0 by 1, which is 0. This is 0. So the reciprocal of 0 is not defined. The reciprocal of not defined is 0. If you see 0, reciprocal is not defined. If you see not defined, the reciprocal is 0. Because not defined means something by 0. Anything by 0 is not defined. So reciprocal will be 0 by here 1, 0 by 1, which is 0. So this is how we remember the table. Now online students, we'll do it again. Help me fill the table. Yeah, so we start with what? Online students? Anybody
Yes.
can start? Yeah, tell me.
Sine 0 degree, ma'am. 0.
Fine. 0.
1 by 2.
Yeah.
1 by root 2.
Okay.
Root 3 by 2.
Root 3 by 2.
0.
1.
1. 0. 1 by 2. 1 by root 2. Root 3 by 2. 1. Very good. Then cos values.
1.
1.
1.
1.
2.
Root 3 by 2.
Root 3 by 2.
1 by root 3. 1 by root 2.
1 by root 2.
1 by 2.
1 by 2.
0.
0. Very good. Tan. You should divide.
0.
Sine by cos. Divide sine value by cos value.
0.
0.
1 by root 3.
1 by root 3.
1.
1.
Root 3.
Root 3.
Not defined.
Not defined. Because 1 by 0 is not defined. Very good. How will we get, from where will we get cosecant values from? Cosecant is from?
Reciprocal of sine, ma'am.
Reciprocal of sine values. Very good. So 0 means what? 0 by 1. What's the reciprocal?
Not defined. Not defined.
1 by 0, which is not defined. Very good. Then
2.
2.
2, ma'am.
Root 2.
Root 2.
Root 2.
2 by root 3.
2 by root 3.
1.
1. Very good. Cosecant. Reciprocal of cos values.
1.
1.
2 by root 3. 2 by
2 by root 3.
Root
2.
Root 2.
2.
2.
Not defined.
Because 0 means 0 by 1. 0 means 0 by 1. 0 means 0 by 1. So here it will be 1 by 0, which is not defined. Very good. And cot is a reciprocal of tan. Yeah.
Not defined.
0 means 0 by 1. So 1 by 0, which is not defined. Then
Root 3, ma'am. Root 3.
root 3.
1.
1.
1 by root 3.
1 by root 3.
0.
0.
0. Because not defined means 1 by 0. So reciprocal is 0 by 1, which is 0. Very good, children. Very good. All of us here also understood clearly, right? Okay. So we know the values now. We'll see how they are derived. It's very simple. So I'll just allow you to watch the derivation and then I'll explain. For deriving listen to me, sorry. For deriving the trigonometric ratios of 45 degrees, we need to use a right triangle with one angle 45 degrees. That's what we have to take. To derive the trigonometric ratios of 45 degrees, we have to take a right triangle with one angle 45 degrees. With one angle 45 degrees. To derive the trigonometric ratios of we need to consider an equilateral triangle. 30 and 60, it's easy to remember again. 30, 60, no? In an equilateral triangle, all the angles are equal to 60 degrees, right? In an equilateral triangle, all the angles are equal to 60 degrees. And if you bisect one angle, you'll get 30 degrees, right? So 30, 60 is equilateral triangle. If you want to derive the trigonometric ratios of 30 degrees and 60 degrees, we need to take up an equilateral triangle because 30, 60. 60 means only in an equilateral triangle, each angle is 60 degrees. But you want 30 also. If you bisect 60 degrees, you'll get 30 degrees. So 30, 60, you should take up an equilateral triangle. And for 45 degrees, you must take a right triangle with one angle 45 degrees. Is that okay? Yeah, go through this. Online students, please go through the derivation. Okay, I'm so sorry again. I'm so sorry. The idea is you should have all the angles. 1 minute, children, please. I think this will help you to understand better. Now, I said here you have to take a right triangle. You have to take a right triangle with one angle 45 degrees. So the other angle also will be 45 degrees. Now the thing is, you know all the three angles. You need to know all the three sides also. You can't find numbers for the sides, but you should find expressions for the sides. Now, if this is 45 and this is 45, it's a right isosceles triangle. It's a right isosceles triangle. So these two sides are equal. So let this be A, this also be A. Then by using Pythagoras theorem, you will get the hypotenuse as root 2A. Now, when you come to this step, you are ready to find the trigonometric ratios of 45 degrees. So what should you have? You must have a right triangle with one angle 45 degrees. So the other angle also is 45 degrees. Now you know all the three angles. You need to fill up the three sides also. Because it is a right isosceles triangle, two sides are equal because 45, 45. So two sides are equal. So we'll call them AA. You can call XX also, anything. So AA. So using Pythagoras theorem, you can find the hypotenuse. So now you know one side is A, other side is A, hypotenuse root 2A. So now you have the triangle with all three angles known and three sides known. Now you can find the trigonometric ratios of 45 degrees. In the same way here, in the next one, you need to have a right triangle. You need to have a right triangle in this one. Okay, so here we first start off with an isosceles triangle, sorry, equilateral triangle. But then you'll see, then we take only one half of it. We'll only take one half of it. We'll only take one half of it. Okay. So there you will have 130 degrees, 160 degrees you'll have, and this is 90. In the triangle, you will have 90 and 60 and 30 because this is perpendicular, so 90, this is 90. And this angle is 60, so this will be 60. And this full thing is 60. And these two triangles are congruent to each other. So it will be 30 here and 30 here. And we are taking only this half here, this half. We're taking only this half here. You can take this half also. Any half you take, you can take this half also. So when you do that, you have all the angles. You have 90 degrees, you have 30 degrees, you have 60 degrees. Now what do you want? You want the sides. Now sides, all the sides are equal. This side is equal to this side is equal to this side. You can take the side as A units. I have taken 2A so that half of it will be A, so that you can avoid the fraction A by 2. If you take A by 2 also, you will get the same ratio. The answer will not change. I've taken 2a so that half of it will be a and it's convenient to work. You can try now. If you're curious as to what will happen if we take a, take a, you will get the same answer. I have taken this full thing as 2a. So since these two triangles are congruent, this part is a, no, triangle. So then corresponding sides and corresponding angles are equal. So this one is a, this one is also a. 2a becomes aa. So that's a here. And this one is 2a because all the sides we've taken 2a, right? All the sides we have taken 2a. Sides 2a. So AC is 2a. AC is 2a. And DC is a. And this one we don't know. So you can find that using Pythagoras theorem. What did I say? You must know all the three angles and all the three sides. So you know all the three angles, 90 degrees, 30 degrees, 60 degrees, all the three angles. Three sides, this side is 2a, we know. This side is a, we know. This side we don't know. So you please find that using Pythagoras theorem. Or you can also use the formula to find the altitude of an equilateral triangle. Yes, online students, what's the formula to find the length of the altitude of an equilateral triangle? Formula to find the length of the altitude in an equilateral triangle. Yes.
Root 3a by 2.
Root 3a by 2. Okay, good. Root 3 by 2a. You said? Root 3 by a, you said? Okay. Root 3 by 2a. Root 3 by 2a. Root 3 by 2 into side. Root 3 by 2 into side is the formula to find the length of the altitude of an equilateral triangle. So you can use that also. So you can find the altitude using the formula root 3 by 2 into a, where a is not a. Side of the equilateral triangle. Don't put a. Root 3 by 2. Root 3 by 2 into a, where a is the side of the equilateral triangle. Don't take a here. That's the formula. What is a? A is the side. A is the side of the triangle. Sorry, so A is the side of the triangle. And what's the side of the triangle? 2a. So 2 cancels, root 3a. See here, root 3a. So you can find the altitude. Normally in books, your NCERT book, they would have used the Pythagoras theorem. So even I have worked that. You can also use this formula, root 3 by 2 into side. Both will give the same result. So the preparation is like you prepare before you step out of your house to go to school. Correct? So like that, you need to prepare before you derive the trigonometric ratios of 30 degrees and 60 degrees. You need to prepare the triangle. So how do you prepare the triangle? You prepare the triangles with all the angles known to you and the sides known to you. So in this triangle, now you know 90 degrees, you know 30 degrees, you know 60 degrees, you know A, you know, excuse me, you know A, you know root, sorry, you know 2A. And we find AD using Pythagoras theorem. So now you have all the sides and angles. Now you can find the ratios. Yeah. This one I want to do, I think if you write, I think, okay, go through children. Go through, keep in mind what I told you. Go through this and I think one of you now can explain it to me. It's not difficult. Go through. Finished? Oh. Can we just come and press that plug now? I think it's loose. Done, children? Yeah, Raja's ready to explain. Yeah. Do you need some more time? The stylus pen is somewhere there. Can you just pick that for me? I'm so sorry. I'm not too, very thin to bend. Otherwise, I don't. Thank you. Ready, children? Went through the working?
Yes, ma'am.
Okay. So let's do that here. Online students, use the emoji, raise your hand. Danya, Raghavi, Sri Krishmi, Rakshita, Prajit, Tanishka. Prajit and Tanishka. Are you there, Prajit?
Ma'am.
Yeah.
Ma'am, I couldn't
Okay.
raise the hand.
All right, Raghavi. Good. Prajit, are you there? So for 45 degrees, what do we need to take up, children? Right triangle with one angle 45 degrees. You need to take up a right triangle with one angle 45 degrees. The question will be like this: geometrically find sine 45 degrees. This will be the question. The question will be geometrically find the sine 45 degrees. That means you should derive. That means you must derive sine 45 degrees. Okay. So right triangle in which one angle is, let's take this one as 45 degrees. Then by angle sum property, this also is 45 degrees. Let's name the triangle PQR. If this angle is equal to this angle, that means this side is equal to this side, correct? So if I call this X, this is also X, correct? And the hypotenuse PR will be PR square is equal to X square plus X square. So PR square is equal to 2X square. So PR is equal to square root of 2X square. So that is root 2 into X units. So this one is root 2X. So now we have the right triangle with all angles and sides known to us. Now let's find sine 45 degrees. Sine 45 degrees is equal to which 45? See, which 45 degrees are you taking? So if you're taking this 45 degrees, you fix it. You can take any 45 degrees. You fix it. So for this 45 degrees, this is the opposite side, correct? And for this, now don't take for this 45 degrees, this is the opposite side. Take 145 degrees. For this one, this is the opposite side. So this is the adjacent side. Now sine 45 degrees is equal to opposite x by hypotenuse. Sine 45 degrees is equal to opposite by hypotenuse. So opposite is x. Hypotenuse is root 2x. So x and x will get cancelled. So sine 45 is 1 by root 2. See, sine 45 is equal to 1 by root 2.
Did you call me?
Yes, Rajat?
Did you call me?
Yes. You were there at your desk?
Yes. Yes,
Okay.
ma'am. I had a single problem. I'm sorry.
Okay, fine. All right. So then cos 45 degrees. Cos 45 degrees. I somehow feel that you both are very good friends and you also get distracted easily. So why don't you put somebody between you both, right? Just come between the boys. Yeah. Thank you. So cos 45 degrees is equal to opposite. Opposite is x. By, oh, sorry, adjacent. I'm so sorry. I was distracted here. It's because of yeah, what's cos 45 degrees? Adjacent. Adjacent is x by hypotenuse, root 2x. So x and x cancels 1 by root 2. Cos 45 is equal to 1 by root 2. Tan 45. Tan 45 is equal to, tan 45 degrees is equal to opposite by adjacent, opposite x by adjacent x. X by x, which is 1. So tan 45 degrees is equal to 1. Now once you find these three, you can easily find the others. The reciprocal of sine 45 degrees is cosecant 45 degrees. cosecant 45 degrees. So that will be root 2 because reciprocal of 1 by root 2, which is root 2. So similarly, what is secant 45? Secant 45, root 2. And cot 45, 1. So this is about deriving the trigonometric ratios of 45 degrees. Now for deriving the trigonometric ratios of 30 and 60 degrees, what kind of I know you didn't see that. What kind of triangle should you take up? Equilateral triangle. Each side is equal to 2A units. I know I didn't give you time to watch this. I think we can do it now that you understood the earlier one. This one will be easy to understand. Each side 2A. Altitude. You should construct the altitude. You must construct the altitude. So what happens? You can prove that these two triangles are congruent to each other, correct? Let me call the triangle ABC. Altitude AD. So these two triangles are congruent to each other. So if this, so BD is equal to DC. So BD is A, DC is also A because the whole thing is 2A. Now slowly we'll detach and take only half of this. A, D, C. And again, because they're congruent, this angle is equal to this angle. Because the two triangles are congruent. The two triangles are congruent. So BD is equal to DC, A units. And also this angle is equal to this angle, CPCT. So this will be 30 degrees and this also will be 30 degrees because the whole thing is 60 degrees. So from congruency, you must say two things. One is BD is equal to DC. The other one is this angle is equal to this angle. That's why we are proving that these two triangles are congruent to each other. So again, equilateral triangle ABC. Drop an altitude AD. Prove that these two triangles are congruent to each other. And then by CPCTC, say this side is equal to this side. Since the whole side is 2A, this will be A and A here. Also, since the whole angle is 60 degrees because equilateral. So by CPCT, each of it will be 30 degrees, 30 degrees, 30 degrees. Now, and then, you know, every. No, you're missing what I'm saying. See, I'm doing it once, twice, thrice for you. I'm not going to write the exam. All right. Now, after showing that the triangles are congruent and getting these things A, 30, 30, take up only half of the triangle. A, D, C. And this is 90 here, so it's 90 here. This one is 30, so this one is 30. This one is 60. We know that no, because equilateral, so it's 60. So this is also 60. All angles are known to us. And side, this is A. This one is 2A. And by Pythagoras theorem, you will find that this is root 3A. You'll find it, you find it. I showed you using the formula also. Here. Pythagoras theorem, work with Pythagoras theorem, and you'll find AD is equal to root 3A. All right. Yeah. Now that's it. Once a triangle is ready, we are ready to write the ratios. So now sine 30 degrees. Now you for 30 degrees, this is the opposite side and this is the adjacent side. But for 60 degrees, this will be the opposite side and this is the adjacent side. The opposite side for 30 degrees is different from the opposite side for 60 degrees. So now we are writing for 30 degrees. So see, this is the opposite. For 30 degrees, this is the opposite side. And this is the adjacent side. So now what is sine 30 degrees? Opposite A by hypotenuse 2A. 1 by 2. Okay, so sine 30 degrees is 1 by 2. Cos 30 degrees. Adjacent by hypotenuse. Adjacent. Hypotenuse. Root 3 by 2A. Tan 45. Tan 45 is equal to opposite by adjacent. Opposite A by adjacent root 3A. 1 by root 3. 1 by root 3. By mistake, I wrote tan 45. Tan 30. 1 by root 3. Correct? Yeah. So tan 30 is 1 by root 3. This is slide. What's the next thing? Cosecant 30. What is cosecant 30? Reciprocal of this one, 2. Secant 30, 2 by root 3. And cot 30, root 3. Now we'll derive 60 degrees. Sine 60 degrees. Now for 60 degrees, this is the opposite side. For 60 degrees, see, this is 60 degrees. So this will be the opposite side and this will be the adjacent side, correct? So sine 60 degrees is equal to opposite by hypotenuse. Opposite by hypotenuse. Cos 60 degrees. Adjacent by hypotenuse. Adjacent by hypotenuse. Tan 60 degrees. Opposite by adjacent. Opposite by adjacent. So you can see sine 60, cos 60, tan 60, root 3 by 2, 1 by 2 and root 3. Then their reciprocals. Their reciprocals will be sine is cosecant, cosecant 60 degrees, secant 60 degrees, and cot 60 degrees. So this will be 2 by root 3, 2, 1 by root 3. Correct? 1 by root 3. Now supposing they ask you find cot 30 degrees geometrically, cot 30 degrees. Find cot 30 degrees geometrically. Then find only cot 30. Like draw the meaning, get this triangle and don't write all this. Don't write all this. How do you derive cot 30 degrees? What is cot 30 degrees? Cot is adjacent by opposite. Adjacent by opposite. So for this 30 degrees, this is the, for this 30 degrees, this is the adjacent side. And this is the opposite side. For 30 degrees, this is the adjacent side, this is the opposite side. Adjacent by opposite. Root 3a. Root 3a by a. Cot is adjacent by opposite. For 30 degrees, This is the adjacent side, this is the opposite side. So root 3a by a. Just root 3. Derive only that. Supposing they ask you to find cot 30 degrees, find only that. What should you have? You should have the triangle with all the sides and angles and find only cot 30 degrees. All right. So that's about deriving the trigonometric ratios for 30 degrees, 45 degrees, and 60 degrees. 0 degrees and 90 degrees was removed from the syllabus. So this year also it will continue. So you just have to remember the value. Like I told you the value, right? What is sine 0, cos 0? You should remember the values, but you don't have the derivation for that. Derivation for 0 degrees and 90 degrees, remove. 30, 45, 60, I told you. 0 and 90 is removed. But you should just remember the values. Okay. So you have only one more to go. This is the table. You have this derivation of trigonometric identities, but you don't have complementary angles. Trigonometric ratios of complementary angles you don't have. This is deleted. So with this one, I'll finish the introduction to trigonometry. Then we can get started with the exercise questions and then the extra problems. So what have we learned so far? This is a completely new chapter, a completely new topic, not chapter. It's a completely new topic for you. So to start off, we understood the definition of trigonometry. Then the 3 words which I used to make this word trigonometry. Yeah, correct. And what is an algebraic identity? What is a trigonometric identity? And then the trigonometric ratios. So basically, a trigonometric ratio connects the angle theta with 2 sides of the triangle, opposite and adjacent, or opposite hypotenuse, adjacent hypotenuse. So basically, a trigonometric ratio connects that or establishes the relation between the acute angle and the 2 sides of the triangle. Because that's how the ratio is defined, right? Now, when we say tan theta is equal to opposite by adjacent. So in tan theta, what do we understand? This angle theta is connected with the opposite side and the adjacent side, opposite by adjacent. So basically, a trigonometric ratio connects an acute angle with 2 sides of the triangle. So that's a trigonometric ratio. And then we defined the 6. We defined the 6 trigonometric ratios, sine, cos, and tan. And then the reciprocals, cosecant, secant, and cot. And we also understood that tan A is sine A by cos A, cot A is cos A by sine A. Okay. And after that, we derived the values of some specific, we derived the values of some specific trigonometric ratios, like sine 30 degrees, sine 45 degrees, sine 60 degrees, cos 30, cos 45, cos 60, and so on. All right. So we just have this one. So here in this slide, we'll see how the trigonometric identities are derived. Trigonometric identities are derived. We derived the trigonometric ratios. We found the values of sine 30, sine 45, sine 60. That is one thing. Then before that, we understood the definitions of trigonometry. That's where we started. We first understood the definitions of trigonometric ratios. Sine 30 is what? I'm sorry, sine theta is what? Cos theta is what? Opposite by hypotenuse, adjacent by hypotenuse, and so on. So we started there. We started with the definition of trigonometric ratios, and then we derive the values of sin 30, cos 30, tan 30, and so on. And next is deriving the trigonometric identities. Sin square theta plus cos square theta is 1. Cosecant square theta minus cot square theta is 1. Secant square theta minus tan square theta is 1. These are the three main trigonometric identities. Okay, so derivation is very simple. Now you need to first take a right triangle. Take a right triangle and mark off any one angle as theta. Any angle as theta. Okay. So I've called this as theta. Now with respect to theta, this is the opposite side. And this is the adjacent side. And this is the hypotenuse because it's opposite the right angle. That's all. You just need to consider a right triangle with one acute angle as theta. With one acute angle as theta. That's all. Now write the result by Pythagoras theorem. Write the result by Pythagoras theorem. What is the result by Pythagoras theorem here? AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. It's a result by Pythagoras theorem. Write that. Okay. AC square is equal to AB square plus BC square. Now, to derive the three identities, we divide. See, can you see this here? Can you see the Pythagoras theorem here, here, and here? 3 times I've written. See the same thing. I've written this here. Can you see that? Here I've divided by AC square. That is the hypotenuse square. Then we divided by BC square. Then by AB square. That's all. When you do this, you get the three identities. You need to take up a right triangle, mark one angle as theta, and mark off the opposite side, adjacent side, and hypotenuse. Then write the Pythagoras theorem. Then write the Pythagoras theorem. 3 times I've written. For three ratios, sorry, for the three different trigonometric identities, I've written it 3 times. 1, 2, 3 times. So if I divide by AC square, that is hypotenuse square, you will get this identity, sin square theta plus cos square theta is 1. See, always when you divide by hypotenuse square, what is AC square? The square on the hypotenuse. When you divide by that, you will get this identity, sin square theta plus cos square theta is 1. When you divide by BC square, what is BC? The opposite side. Opposite. When you divide by BC square, you will always get this identity, cosecant square theta minus cot square theta is 1. And when you divide by adjacent square, that is AB square, then you will get this identity, secant square theta minus tan square theta is 1. Okay, so writing the Pythagoras theorem, dividing by AC square, then you understand this also. This one can be written as, so you can see here, I've divided by AC square everywhere. This one by AC square, this one by AC square is equal to this one by AC square, correct? That's what you have here. So this is nothing but BC by AC, the whole square. This is AB by AC, the whole square. This one is AC square by AC square, which is 1. Now, what is BC by AC? What is BC by AC? What is BC by AC? Opposite by hypotenuse. Opposite by hypotenuse, sin theta. Why are we saying sin theta? Because with respect to theta, this is the opposite side, this is the adjacent side. So sin theta. So sin theta. Now you will say, what if I forgot to mark this as theta? Then you would have taken some angles. Maybe then with respect to A, you have marked opposite and adjacent. For this angle A, this is the opposite side. And for angle A, this is the adjacent side and this is the hypotenuse. Then you should write here sin A. Sin A the whole square. If you didn't mark this angle as theta, you must write sin A. Because for angle A, this is the opposite side. What is AB by AC? AB by AC. AB by AC is adjacent by hypotenuse. Adjacent by hypotenuse is cos A or cos theta, the whole square. So this one is sin theta and this one is cos theta, whole square is equal to 1. Now, sine theta the whole square is written as sine square theta. Sine theta the whole square is written as sine, is written like this and read as sine square theta. This is, that is sine theta into sine theta. Sine theta the whole square means what? What is sine theta the whole square? Sine theta into sine theta. And sine theta into sine theta is just like algebra. A into A is A square. A into A is A square. Similar to that, sine theta into sine theta is sine theta the whole square, which is written like this and read as sine square theta. We don't write sine theta square like this. This is wrong. It's written like this and read as sine square theta. Sine square theta means sine theta into sine theta. Cos theta the whole square. Cos theta into cos theta is written like this and read as cos square theta. Cos square theta means cos theta into cos theta is equal to 1. All right. So next here, when you divide by BC square, this is 1 and AB by BC. AB by BC. Adjacent by opposite. Adjacent by opposite is cot. Cot. Adjacent by opposite is cot. So cot theta. The whole square. Similarly, like that, AC by BC, children. AC by BC. This one. Hypotenuse by opposite. Hypotenuse by opposite is cosecant. So cosecant theta and whole square. So we get 1 plus cot square theta is equal to cosecant square theta. When you transpose, you can write cosecant square theta minus cot square theta is 1. On transposing, you can write it like this. When you take this here, cosecant square theta minus cot square theta is equal to 1. When you take this here, cosecant square theta minus cot square theta is equal to 1. Yes or no? And finally here, AB square by AB square is 1. BC by AB is tan theta. AC by AB. Why BC by AB is tan theta? BC is opposite. AB is adjacent. Opposite by adjacent is tan theta. Tan theta the whole square. AC by AB. AC, hypotenuse by adjacent. Hypotenuse by adjacent. What is hypotenuse by adjacent? Secant. So secant theta the whole square. So tan square theta plus 1 is equal to secant square theta. When you transpose, you get secant square theta minus tan square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. So these are the 3 important trigonometric identities are derived. So we'll just read them. The identities are sine square theta plus cos square theta is equal to 1. It can be A also, any angle you can say. You can say sine square alpha plus cos square alpha is equal to 1. But the angle should be the same. You cannot have alpha here and beta here. Then it is not 1. Then it is not 1. Sine square alpha plus cos square beta is not 1. Angle must be the same. Sine square theta plus cos square theta is 1. Cosecant square theta minus cot square theta is 1. Secant square theta minus tan square theta is 1. All right. Yeah. So this is the other ways in which we can interpret the trigonometric identities. The other ways in which we can interpret the trigonometric identities. Go through that. So we are trying to write sine square theta in terms of cos square theta and cos square theta in terms of sine square theta. So sine square theta is equal to 1 minus cos square theta. correct? And 1 minus cos square theta is in the form a square minus b square. So it is a plus b into a minus b. 1 plus cos theta into 1 minus cos theta. So sine square theta is this. So sine theta will be the square root of 1 plus cos theta into 1 minus cos theta. We're just trying to find the other ways in which we can understand the identities, the other interpretations. That's why the heading is interpretations. The different ways you can interpret the identities. Interpretations of the three fundamental trigonometric identities. So sine square, when you transpose this, sine square theta is equal to 1 minus cos square theta. This is like a square minus b square, which is a plus b into a minus b. So sine theta will be equal to the square root of, because sine square theta is this. So sine theta will be equal to square root of the RHS. Now here you have cos square theta here. So that is equal to 1 minus sine square theta. So cos square theta is equal to, this is like a square minus b square. So a plus b into a minus b. So cos theta, cos square theta is this. So cos theta will be equal to the square root of the RHS. Now the next one, the second identity, cosecant square theta minus cot square theta is 1. So cosecant square theta will be equal to 1 plus cot square theta. So cosecant theta will be equal to square root of 1 plus cot square theta. Again, now you transpose something else. So when you take this here, see here, you will get cosecant square theta minus 1 is equal to cot square theta, correct? Cosecant square theta minus 1 is equal to cot square theta. In other words, cot square theta is equal to cosecant square theta minus 1. Arjun, correct? Cosecant square theta minus 1. See here, on transposing, here we have cosecant square theta alone on one side. Here we are going to have cot square theta alone on one side, cot square theta alone on one side. So if you take this here, it will become plus cot square theta. And here you have cosecant square theta. And this minus plus 1 will become minus 1. So that's what is it? It is cot square theta is equal to cosecant square theta minus 1. So cot, now this is like a square minus b square. This is b square. A plus b into a minus b. So cot theta is equal to square root of the RHS. All right. See here it was 1 plus cot square theta. So nothing. But here it is cosecant square theta minus 1. So this is like a square minus b square. So a plus b into a minus b. And cot square theta is this one. So cot theta will be equal to square root of the RHS. Correct? And finally, interpret the identity as it is. Cosecant square theta minus cot square theta is 1, right? So that's like a square minus b square. Cosecant square theta is a square, cot square theta is b square. So a square minus b square is a plus b into a minus b. Cosecant theta plus cot theta into cosecant theta minus cot theta is equal to 1. So if you have a into b is equal to 1, a is equal to 1 by b, b is equal to 1 by a. Correct? Similarly, cosecant theta plus cot theta will be equal to 1 by cosecant theta minus cot theta, because this is like a. Just look at this one as a and this one as b. A into b is 1. So what is a? 1 by b. And what is b? 1 by a. Correct? This one is equal to 1 divided by this one. And this one is equal to 1 divided by this one. And there's a third identity, secant square theta minus tan square theta is 1, transpose. So secant square theta is equal to 1 plus tan square theta. So secant theta is equal to square root of the RHS. Here, take this one to the side. So it becomes positive. Tan square A becomes positive. This one here. So it'll be what? Secant square theta minus 1. This one will come here. Minus 1 is equal to tan square theta. Secant square theta minus 1 is equal to tan square theta. So that means tan square theta is equal to secant square theta minus 1. Tan square theta is equal to secant square theta minus 1. That's what I've written here. So tan square theta is equal to, this is like a square minus b square, because this is b square, 1 square. So it's a plus b into a minus b. So tan theta will be equal to the square root of the RHS. And finally, the identity itself is like a square minus b square. So it is a plus b into a minus b is equal to 1. So this is like a into b is equal to 1. So a is equal to 1 by b, and b is equal to 1 by a. So with this we come to the, this is deleted. So with this we come to the end of the lecture on introduction to trigonometry. So using all these concepts or using this knowledge, you will be working the exercise problems from NCERT and other books. All right. All right, children. We just have 5 minutes left, but I'll wind up the session. I think if I start anything beyond this, I cannot finish it in 5 minutes. Okay. All right, online students. So that's it for today's session. Thank you so much. You may leave the call.
Thank you,
Thank you.
ma'am.
Thank you. Good night. Thank you, children. Good night. Share the picture of your question paper, no? How did it go? Exam at school?